A cable in a bridge is required to support a weight of 10,000 newtons. Tina tests a random sample of 100 cables from a supplier. The sample mean is found to be 10,300 newtons and the sample standard deviation 400 newtons. Based on Tina's sample, obtain a 95% confidence interval for mu, the population mean cable strength. So we know that the sample mean was 10,300, and then we've got to take away an amount, which we'll come to in a moment, and then we've got 10,300 add that same amount to form our interval. Now we're after a 95% confidence interval, so we need the z-score for 95%. So we go for inverse normal CDF. If we go for a center, 0.95, leave this as 1 and 0 because we're after a z-score, and that is 1.96. So we'll have 1.96 multiplied by the sample standard deviation was 400. Divide that by the square root of 100. There were 100 in the sample. And then we add that same amount here. So we have got 10,300 take away 1.96 times 40, 10221.6, and just change that in the middle there to a plus, 10378.4. State whether each of the following statements is true or false. Provide reasons for your answer and state any assumptions. If another sample of 100 cables is taken, then the sample mean will fall within the confidence interval found at part A. This is false, and that's the first thing you should state. This mean would be based on a different independent random sample. So there's no guarantee that that sample mean would fall within this confidence interval. In fact, it's a 95% confidence interval. So that tells us that we're not 100% confident that a sample mean would lie in there. If a single cable is selected at random, then the strength of the cable will fall within the confidence interval found at part A. This is also false. A single cable has a much greater variation than a sample, so the standard deviation would be larger. It's actually much more likely for a single cable to fall outside of the confidence interval. John, a colleague of Tina, said the cable strengths are not normally distributed, so the calculation for the confidence interval is incorrect. How should she respond to John's comment? Well, her n, remember, was 100, is greater than 30. So the underlying distribution doesn't matter. The sample means should still be normally distributed. And this is, of course, the central limit theorem. A different sample of 36 cables is taken, and it's found that the standard deviation is 500 newtons. The confidence interval for the population mean cable strength is determined to be 9,900 to 10,200. Determine the confidence level to the nearest 0.1% used to determine this interval. Well, we'd like the width of the interval, so 10,200 take away 9,900. And that gives us a width of 300. So that's the total for the entire interval. That's 300, which means from the mean to the outside is 150. Now remember what calculation does that. So it's the z-score multiplied by the standard deviation divided by the square root of the number in the sample. And we know that that's going to be equal to 150. And therefore our z value is 150 times 6 over 500. So 150 times 6 is 900, and divide that by 500, and that's 1.8. So we want to know the probability associated with that. So if we go to continuous and normal CDF and take a lower of negative 1.8 and an upper of 1.8, so 1.8 standard deviations either side of the norm, and that would give us 0.928. So the probability is 0.9281 and so on, and so we would say that's a 92.8% confidence interval.